let me clarify, because I can see, in the chat box who claimed uniform acceleration in space audits. The same globurists do. But it's not just the globe, it's the same. The stationary Earth is claiming the same thing.
Yep.
If I let go of the bottle and there's a downwards acceleration, and I'm saying, well, there's no sign of downwards acceleration because the gases and the liquids are not showing me that, then the stationary flat earthers are saying that it's all moving towards the Earth at the same rate. That it's not just the globe Earth. This is stationary earthers really need to comprehend their position. If I'm sitting here in a stationary Earth and I'm holding something in front of me with gas and liquid in it, and I let that go, the default position of a stationary Earth is that the thing I am holding and its contents are all accelerating towards the Earth at the same rate. That's your default position. So it's no that it's just the globurists that are claiming that. That's stationary flat Earth's default position.
Yeah.
Yeah, but the bottle is trapping the gas, so it's naturally gonna pull the gas down the same rate, right?
No, Brian. If I physically accelerate that bottle downwards, right, what happens is the air that's at the top of the bottle now moves to the bottom of the bottle, and the liquid moves to the top of the bottle, because air moves towards the direction of acceleration, right? You can see that anywhere you like. You can try it. Get something with an air bubble in it and accelerate it. The air bubble will shift towards the direction of acceleration. So if I'm holding a bottle with air at the top and water at the bottom, and there's a claim that there's now a downwards acceleration, I should see an inversion of the gas and the liquid within the bottle. But I don't. So stationary earthers are now claiming that it's because the bottle, the gas and the liquid are all accelerating downwards at the same rate. That's a position that's totally ludicrous. It's no founded.
I see what you're saying now. I get what you're saying now. I think Alan wanted to question.
Yeah, I was going to say, and to be fair, I wasn't just chopping it off at globularist. I did type the rest of what you were addressing.
Sorry, I didn't see that.
No, you're straight, bro. But to add on to that, so the agreed upon average, like they do tell the globularist, and it's not really their fault. They do tell us all that the 9.8 meters is everywhere or whatever. But again, with the gravimeter, which is basically using interferometry again for the measurements, they do find that there is a variance in what they call that gravitational downward acceleration, and it's not actually as 9.8 meters as they say. So there is fluctuations within that.
And that's fine, but the main contention is the claim that there's a downwards acceleration, and my point is there is no downwards acceleration. So I don't need to go any further and engage in the topic of downwards acceleration, because there is none.
Yeah. So let me ask you this: what would you say to the object's falling, right, and it's reached its equilibrium, right? Its terminal velocity, as you said, it's no longer accelerating, right? But it's in what we call free fall, right? So the medium inside of that, like there's like the motion inside of that is displacing it. So there needs to be pressure mediation within that, right? It needs to equalize. So while that needs to take place, as it's free falling from that motion, the air bubble and whatnot are acting in correspondence to that motion while the pressure mediation is ensuing.
So all accelerating uniformly?
No.
So it's not all accelerating uniformly then. That's my point.
I agree.
Aye, that's my point. There is, if acceleration was at play, you would see that happen. It would be witnessed physically,
bro. Well,
it's no witnessed physically.
Yeah. So not to cut you off, but like I was saying earlier, kinematically, what you're saying tracks like perfectly. Like you just have a different interpretation of the mechanism of that. So instead of saying like downward bias, and then the buoyancy density situation of the medium facilitates the rate of which the free fall transpires, right? So what you're doing, in my opinion, well, not my opinion, what you're doing is you're just replacing that with upward deceleration. And kinematically, it's true. So your position is unfalsifiable, as well as mine, right? As well as the gravity's situation, kind of. But in terms of uniform acceleration. But yeah, that's why your argument is so sound, because it's true. Like we're seeing the effects, but you're just describing it under a different way, and then saying the other one doesn't work. but I think a more rounded position would be to acknowledge the kinematic equivalence between the two positions. Because I've been listening to you argue it all night, looking for some fallacious stuff, and like honestly, it's way more intricate than I had originally anticipated. But at the end of the day, what I'm seeing here is like we have an equivalence in what we're saying. We're just saying two different things, and you're kind of just not acknowledging the other.
Well, it's because mine is based in practicality. If you can demonstrate your position, then I'll have a look at it and I'll accept it. So, so if you demonstrate for me your position physically, then I don't have any issue with that. The issue is that we've got these claims of physicality, and we're no witnessing the physical effects or what we should see in these conditions. So, I mean, again, what other explanation or conclusion is there for me to come to if I'm holding that thing and I'm connected solidly to the Earth, and then when it's no longer solidly connected to the Earth, we don't see the vector anymore. There's no pressure within the vessel. There is no directionality. There is no pressure gradient. There is no buoyancy and density gradient. It just goes. If it was in free fall and I could slowly increase the viscosity of the air, we would start to see that displacement occur again. We would start to see buoyancy and density taking effect because now I'm increasing the viscosity. The motion transfer of the Earth can now be felt through that body. Yeah. So if I drop it in liquid, it's still there because a liquid can push up and support and cause the motion transfer through the matter. But in air doesn't have that ability, so we don't see that motion transfer witnessed anymore. Anyhow, listen, guys, I'm sorry, I'm going to need to drop out. I've got stuff I need to go on with here. It's still 10:30 in the morning. I really appreciate the time, and obviously, I was a bit concerned that you lot were going to act like the usual, troll and try and obfuscate and whatever, but it doesn't seem to be the case. So,
nah, this is level heads, man. We don't do that over here. Everybody's
You can
welcome.
talk about anything, yeah. You can talk about anything, man. Like, I'm still on the fence. I do want to try what you're describing. I don't want to say that it's impossible because it might be possible, but maybe I'll surprise myself. But yeah, if you can't discuss something here, then you can't discuss something anywhere.
Yeah, for real. And man, like you clearly put a lot of thought into this, and I've definitely you've gotten me to think about some things regarding relative motion that I need to be thinking about more. And I think like what you're kind of bringing up here is that until we can actually prove something, some other kind of pushing force, we don't really have a lot of ground to stand on to really argue much else other than what you're arguing. And I'm not saying that I necessarily believe that to be the case, but if I don't believe that to be the case, then I have to prove my claim, right?
Yes, exactly. That's what it comes down to here. There's no personal issues here. I have no bias. If you can practically demonstrate, just like any other engineer and mechanic, if they practically demonstrate something to me, that's reality, I accept it.